Light and optics. Light as a modern scientific tool. From the first spark of fire to the most cutting-edge LEDs and lasers, human beings have learnt to use light as a fundamental tool. Lasers make use of the principle of electron transition in atoms. By bombarding them with photons, we excite the electrons of an atom to a higher energy level. If a photon strikes an electron that's already in the excited state, the electron will release an additional photon. Light amplification occurs when the highest number of atoms are excited and photons hit already excited electrons. The atoms are then continuously re-excited with additional energy. Mirrors are used to reflect the photons, which produces further interactions between the light quanta and the excited electrons. The term laser is actually an acronym that stands for this principle. The Nobel Prize in Physics was awarded to Arthur Ashkin, Gérard Mourou, and Donna Strickland in 2018. Ashkin's work uses lasers as optical tweezers, enabling biologists to hold proteins, DNA building blocks, and cell organelles in place without damaging them. Another type of artificially generated light is that from light-emitting diodes, or LEDs for short. Today, LEDs are commonly used as an energy-efficient light source. Before it was possible to use them as a light source, LEDs were utilized only for data transmission or as indicator lights. In 1962, Nick Holoniak Jr. unveiled the first red LED. Green LEDs were invented by George Crawford in 1974. But it wasn't until 1992, with the aid of a gallium nitride crystal, that the first blue LEDs were created. For the first time, it was possible to make white light as a combination of red, green, and blue LED light. Hiroshi Amano, ISAMU AKASAKI, and Shuyi Nakamura received the Nobel Prize in Physics in 2014 for their development of blue LEDs.
This is the blue LEDs. By adding this yellow film, we can easily realize the white LEDs. Okay? Then the application of blue LEDs have been expanded, not only to the display, but